In today's video, I'm going to show you how I set up my development environment in order to develop code for the Raspberry Pi. I received a comment on another video asking about uploading code to the Pi, and I thought it would be good to clarify that I'm doing all of my development on the actual Raspberry Pi, so there's nothing to upload. I do use Git in order to push code to a Git repository for backup purposes, but everything is being developed and saved onto the Pi itself. However, I do use Visual Studio Code in order to communicate with the Raspberry Pi, so all of my development activities are being done on my laptop. If you enjoyed today's video, please like it, subscribe to the channel, and share with your friends. The first thing we have to do to set up our development environment is to set up our Raspberry Pi, and we will install the Raspberry Pi OS onto an SD card that we will load into the Raspberry Pi to launch and run. We will use the Raspberry Pi Imager application to create the SD card, and that can be found at raspberrypi.com/software. So I'm using Windows as my main development machine. These instructions should work just as fine for a Linux development, Ubuntu, and potentially a Mac OS, although I've never tried it with that. So we'll download the Raspberry Pi Imager application and install it. After installation, we will go ahead and run the Raspberry Pi Imager application. In the Imager application, we will choose the device. We are going to set up a Raspberry Pi 4. We will choose the operating system. I'm just going to select the Raspberry Pi OS 64-bit. This is going to give us a desktop version of the Raspberry Pi operating system so that you can connect a monitor to it and get into the GUI or the Windows system. Generally, we're not going to do that when we actually use the board, but I like installing this version just because it gives you the option to connect a monitor and keyboard to the Raspberry Pi and see what's going on. If you don't have that option, it can be a little bit tricky to debug issues later, depending on your comfort level with SSH and the command line. If you want to, you can select other versions. The Raspberry Pi OS Lite version is the one that won't install the Windows graphical user interface system. That's a good option if you know that you will not be connecting it to a monitor or keyboard, or if you're very comfortable with the command line. You can also install other flavors of operating system. Ubuntu, I've used this one and had success with it. For today and in general, I would recommend the Raspberry Pi OS 64-bit with the desktop and everything. So we select that. We select the storage medium that it's going to go in. I have an SD card mounted to my computer or connected to my computer. So I'm going to select that. My laptop has a built-in SD card reader. Maybe you have a USB adapter. Just make sure you're selecting the correct storage device for the SD card. When we click next, it will ask us if we want to apply OS customizations to the SD card. I recommend that you do customize the SD card. So I like to set the host name to something known. I have multiple Raspberry Pis, multiple computers, so I like to give it a well-defined name. In this case, it's going to be called Twirl. I set a username and password on the device, so this lets me SSH into the device or log in a little bit better. A little bit of security, so this is my typical username and password. Here you can configure the wireless LAN before you even plug in to or launch the Raspberry Pi. Make sure these are correct. There's no way to verify. You're not selecting from a list or anything. So make sure that you are entering this information correctly, because if you don't enter it correctly here, when you go to the board, it's not going to connect correctly. ideally, I'm going to just create the SD card, boot in, and then remote desktop or SSH into the board, and I don't ever have to actually do anything with the keyboard or mouse on the actual Raspberry Pi. But if you don't set this up correctly, then it may end up having to go to the Raspberry Pi and making changes. This is another reason why having a desktop install is helpful, because then you can do everything through the GUI instead of making changes from the command line. I also make sure I set the locale settings so the time and date on the board are correct for what I need. Under services, I enable SSH. This was what will allow me to SSH into the board after we've got the SD card set up. And I go ahead and set use password authentication. You can select allow public key authentication and it will create a public key for you. We will do that later on as an optional portion of the setup. For now, I just like to use password authentication, especially since I will already have some SSH keys that I will want to reuse. We don't change anything under options, and then when that's done, we hit save. Once we've set the customization settings, we go ahead and hit yes. It will give you a warning, ask for verification that you do want to erase all the data on the SD card and that you're sure. I am sure. And then it will go ahead and write all the data to the SD card. Once the creation of the SD card is complete by the Imager application, we will get this notification. We hit continue, and then we remove the SD card from our computer. I then take that SD card and load it into the Raspberry Pi and power it on. I've connected a monitor to the Raspberry Pi just to see what is happening on boot, to make sure that the Raspberry Pi does boot correctly, but I have not connected a mouse or keyboard. Ideally, I'm going to SSH into the board to do everything else going forward. The monitor is primarily there just to ensure that it boots up correctly the first time. Once that happens, I will disconnect the monitor, and most of the time I will not have a monitor connected to the Raspberry Pi at all. Once we connect this to a robot or our system, we generally will not have a monitor attached to that. Kind of prefer to use it in the state that it will be in primarily. Okay, we can see from the monitor that the Raspberry Pi has booted correctly. So now I will attempt to communicate with it. First thing I'm going to do is to ping the name of the device, which we know is from Twirl, sorry. We can see that I can ping it and I have the IP address of it. The next thing I want to verify is that I can SSH into the device, and I do that with SSH, my username @Twirl. It'll ask me for the fingerprint, say yes, and then enter my password, and now I've SSH into this device. On Windows here, I am using PowerShell. I prefer to use PowerShell as my terminal on Windows. You can use regular command prompt, or you can get the newer Windows terminal application. Again, I personally prefer PowerShell. It's just a little bit more powerful, in my opinion, for certain things, and is the closest, or at least closer to the Linux command line, and that lets me switch easily between Windows and Linux without having to keep track of too many differences in terms of commands. So now that I have successfully SSH'd into the Raspberry Pi, I can go ahead and continue on to the next step of the setup process. I do all of my development using Visual Studio Code, and we're going to have Visual Studio Code on my main development laptop, and we're going to use remote development features of VS Code to remote into the Raspberry Pi and do the work on the Raspberry Pi. So I go to code.visualstudio.com and download the Windows install for this application. and then I go ahead and install Visual Studio Code. I select the defaults for all of the options during the install process. And then once the install is complete, I launch Visual Studio Code. If you've never used Visual Studio Code before, you can run through their Get Started tutorial or guide. This is common for me, so I'm just going to skip ahead to that. You can feel free to do that on your own. The first thing we're going to do with Visual Studio Code is install the remote SSH extension. So you click on the extensions tab here on the left hand side, and we do a remote search for the word remote. And you'll see there's a number of options. I'm going to just install the remote SSH package here, or pack. There's a remote development here, which allows you kind of more things for remote development. So using Windows subsystem for Linux because we're on Windows, or if you are going to use dev containers, etc. There's a tunnels option, which is a separate, I think, proprietary communication mechanism. We're going to use SSH, or I prefer to use SSH. So I'm just going to install remote-ssh extension pack. And you can see that comes with this extension that lets you modify the SSH config files, and this extension called Remote Explorer, which lets you view all the different remote connections that you have. And once it's installed, we'll see we now have this new tab on the left-hand side, the Remote Explorer. So this is where all of our remote connections will be listed. If you have more than one Raspberry Pi, you'll see them listed here. Once I have done that, I want to add my new Raspberry Pi remote. So I click on the plus sign to add a new remote, and I enter in the SSH command that I want to use. I'm going to use the same one that I used earlier, just a basic SSH into twirl with my username. It's going to save that configuration and ask me where I want to save it. I'm going to save it in the user SSH config file, which is under your user directory.ssh/config. So if I click that, adds it, and then I can go to open config to see what the configuration that was added is. I refresh my remotes on the left side here under Remote Explorer, and now I have a remote listed to twirl. I can then click on this arrow to connect to twirl in the current window. So I can either create a new window to the remote, or I can just connect to it in the current window. Since I'm only working with one remote device today, I will just connect to it in the current window. That closes the window and reopens it, and then starts a connection to the remote. And you'll see down here, it says setting up SSH host twirl, initializing VS Code server. And it asks me what platform the remote host is. What is happening is that Visual Studio Code is going to install some application on the Raspberry Pi, so it needs to know what type of platform is on the remote host so it can install the correct binary. So I'm going to install Linux here. And now the Visual Studio Code running on my laptop is going to communicate with the Visual Studio Code server running on the Raspberry Pi. And that's how I'm going to be able to do work on my laptop, but have it affect what's happening on the Raspberry Pi. It asked me for my password, so I go ahead and enter my password on twirl, and it goes and does the download and install of the VS Code server on the Raspberry Pi. Tells me that it's going to save off this information about Linux being the operating system on the remote. I don't want to see that again, so I click that. And now I have a Visual Studio Code session or window that represents me working directly on the Raspberry Pi. So now I can do all of my work on the Raspberry Pi, and it's going to be saved there and running on the Raspberry Pi itself. So now you want to go ahead and clone our Raspberry Pi for examples. You can click on clone repository here, and then it will ask you to log in, I think, to GitHub or however else you want to get to accessing that information. I personally prefer to just do some of this stuff by the command line. So there are two ways you can do this. One is you can click on New Terminal, and that will open up a terminal here inside of Visual Studio Code. As you can see, it tells you that I'm on Twirl. You can also do that from a second terminal window like PowerShell. Just depends on what you feel comfortable with. I go back and forth. Sometimes I'll do stuff inside of Visual Studio Code, and sometimes I'll do stuff in a separate terminal. Just depends. One of the challenges with the VS Code is you can't kind of pop this section out to have it be two separate windows. So when you're using the built-in terminal in VS Code, you lose some of your code editor real estate. So depending on what you're doing and how important that is to you, one way may be better. In this example, I'm just going to do everything in the terminal, and most of the things I think I'll be doing in the terminal built into VS Code. But again, if the loss of real estate is a bother to you, I also will switch between VS Code and a PowerShell terminal just to be able to keep things a little bit more separate. And it's also easy to switch because you can just Alt-Tab between the things. So the first thing we want to just verify is that we have Git on the Raspberry Pi in order to clone the repository. So just check Git version, verify that it is installed. If it's not, we can install Git using apt, sudo apt install Git. And that will install it for you. It's always a good idea to just do a sudo apt update to make sure that you have all of the latest apt repository information updated. So recommend doing that every now and again, maybe right before you run your first apt command for the day. So we have Git installed, so we can now clone the example repository. And this is the URL for the example repository that I've created. It will put this into our user folder here on the Raspberry Pi. So we execute that, and now it's cloned. So we do an ls to list things. We'll see the rpi GPIO example folder. Now that that is available, I can go ahead and open that on the in VS Code. I select that, and now it will relaunch VS Code with this folder, and I don't really know why it needs to relaunch, but it does. It will ask me some information again. Enter my password. Do I trust the author? Yes, I personally do, since it is me. And now we have our files here, our folder. The next thing you want to do is install our C++ extension pack. So although we have all this installed, we can't do anything C++ related, or at least it won't give us some of the options that we were looking for, such as IntelliSense, etc., because it doesn't know how to handle C++ code yet. Visual Studio Code doesn't. In fact, if I open up the ACPP file, it will ask me, do I want to install the recommended C++ extension pack? If we click on Show Recommendations, it will take you to the extension pack that it wants to install, and we can see that it will install C++ tools as well as cmake tools. So this is what we want, so I'm going ahead and just run install from here. Once that is installed, you'll get a number of notifications just telling you some stuff about cmake changes. If you've used cmake before, some things have moved around. That's fine. I'm going to show that again. Do I want to use a pre-release version of C++ extension? I'm going to say no. Just I prefer using release versions, not pre-release versions, unless there's a reason for using pre-release. Then I'll ask if you would like to configure your project that you have installed. You may or may not get these notifications just depending on which version of VS Code you're using and when you're doing this. I'm going to say no for now in terms of configuring the project. And the reason for that, I'm going to say no, don't configure projects on opening, at least not for this. I like to say never, and I like to manually configure things. I just don't want VS Code doing too many things automatically for me. That's kind of just a bit of my preference. But there are a couple of things to note when cmake and the automatic configuration is going to run. The way this GPIO example project is set up is that it's set up more as individual folders. So each of these folders is kind of a separate project. So you can't really configure the entire folder. That's not possible. They're individual projects under a top-level repository. So when you do this and you try to configure the top-level project, it's going to ask you which thing you want to configure. What I like to do is to add a second folder or add each individual folder to a workspace. So I click on Add Folder to Workspace, and I select the PyGPIO folder, and now it will add that to the workspace. In order to do that, it has to reload the Visual Studio Code window. So now we have a workspace with two separate folders in it. So VS Code kind of has two different modes of use. One is I'm using just a single folder, and the other is a workspace, which consists of multiple folders. So now I have the top level repository folder here and the individual project folder. The advantage of having the individual project folders is now cmake can detect which project you're referring to. You'll see down here we have some cmake tools. I can now configure this individual project. So even though they're together in a single repository folder, I can treat these as different projects or cmake projects, and Visual Studio Code will be able to configure and use them separately. And will actually detect the correct project based on which file I have open. So it knows that this flash led.cpp file is associated with this PyGPIO cmake project because of the fact that the project or this folder is a top level thing inside of a workspace. So I want to configure this project, and I go ahead and click build. I say, yes, I'm using this GCC, whatever. Oh, wait, there's a bad cmake executable. And that's because we haven't installed cmake onto the Raspberry Pi as yet. So to do that, we go back to terminal, and we need to install cmake. So sudo apt install cmake. While it's happening, if you look at the problems, it will tell you that there are some issues with the include path. It can't find fmt/core-h header file. And in fact, if we try to build this again, now that cmake is installed, we will see that it runs cmake, but when it tries to build it, it gives us a bunch of build errors saying we can't use fmt core. This is the libfmt library that we use for some of the formatting in the code. So in order to get that functional, we also need to install the libfmt-dev package. Now that we've installed that, we click build, and everything will build for us. And notice that it's building only the files associated with PyGPIO because PyGPIO is the top level folder in the workspace and the active file is this flash LED CP under PyGPIO. It built successfully, and I can go to my terminal and now go and run the different, CD, run the different applications. So if I go sudo flash LED4, we'll see on our board that the LEDs are flashing because I've connected up my board to LEDs as in previous videos. Now you may have noticed that one of the things that happens quite often is this reloading of the window and this prompt for your SSH password. That can be annoying pretty quickly. So one thing I recommend to do is to use SSH key pairs to set up SSH so that you don't have to enter your password every single time. Easiest way to do this is to go to PowerShell in Windows. Don't be SSH'd into the device. So this is just a regular PowerShell. And then run ssh-keygen. Go ahead and save the key to the default place, which is your user folder .ssh/id_RSA. I don't enter passphrase, but you can enter one if you want. I don't know what happens if you do enter one. It'll generate that private public key pair. And then you can use this command to automatically push it over to the board. So change the username to my name, change the host name to the host name or the host IP address, and then enter this command, enter your password, and then it pushes that over. So what this did was it took the contents of your just generated SSH public key and then SSH'd over to the device, created a .ssh folder on the Raspberry Pi, and then pushed the contents of your public key into this folder, this file called authorized keys. And it did all that in one step for you, so that's pretty helpful. Now that we have the SSH key installed on the Raspberry Pi, your public key, and your private key is installed on your laptop, I can connect to the Raspberry Pi without having to enter my password. So now if I go back in and SSH to Twirl, you notice that I didn't have to enter my password. And the same is true for the Visual Studio Code. So if I go ahead and close that remote connection and now reconnect, so I can click down here as another option, connect to host, Twirl, which opens a new window, opening remotes, setting up the Visual Studio Code on the remote. But notice I didn't have to enter my password because I've created that SSH key pair. Let me go ahead and open up the workspace. It's going to reload the window again, and now it loads up the same folders as before. So again, notice how Visual Studio Code will reload the window multiple times depending on what you're doing. And if it's doing that and you don't have SSH keys set up, it's going to ask you for your password every single time. And that's how I set up my development environment when I'm developing for the Raspberry Pi. I use Visual Studio Code for a wide variety of things, so it's nice having a consistent experience between both desktop applications and the applications on the Raspberry Pi. Visual Studio Code also gives me a lot more features, as some of the features can be running on the desktop version of Visual Studio Code, and then the commands for building, saving, etc. is being sent over the remote connection to the Raspberry Pi itself. That's it for now. Talk to you soon. Later.